I'm just drawing some of the, hold on, turn my mic on. I'm just drawing these veins here. Those are the ones I want you to know. So we make these a different color. All right, so that's the anatomy. Just know those blood vessels. I just kind of charted it out here. Now the reason why I want you to know these blood vessels, even though I'm teaching the heart, if you study our blood vessels on the heart, let me see there. On the big hearts, you'll see this anatomy. Okay, and I've even been asked what I think is kind of a dumb question. When you study the heart, do I have to know the blood vessels that are shown on the heart? Of course you do. If it's there, I'm going to ask it. Okay, so here are some of the blood vessels shown on the heart. This is the main vein of the neck. It's called the internal jugular vein. That's the subclavian vein, and you have it on one side and the other. And the left is a little different from the right. Look at the brachiocephalic vein. The left and the right. Which one's longer? The left or the right? The left is longer, and there's a reason for that. What side is the vein on? It's on the right side. The subclavian vein drains into the right atrium. So that's why the left is longer, because it has to go from the left side to get to the right side. So that is one difference between left and right. We'll move on. There are other chest veins that drain into the subclavian vein here. Right down these two, the azygous and accessory hemiazygous veins. Let's see if we get those down I'll just say that they drain the chest wall. You can kind of look at the picture and get that sense. They're kind of like in the intercostal spaces. So they drain blood from the thoracic cage. Ultimately, they drain into, oh, I can't spell this more. They drain into superior vena cava. That's what's shown on the picture there. I'll move on from that. Another anatomy tip. Oh, I already mentioned this. The left is longer than the right. Move on from that. Okay, this one, other useful anatomy is the subclavian artery and vein. They straddle this muscle called the anterior scalene. The artery is always behind it, but the vein is always anterior to it. So I'm going to put that down. So the anterior scalene is a muscle, and it's a landmark muscle. It's a neck muscle, but I want you to know it because this artery is behind it. Subclavian vein is anterior to anterior scalene, okay? So there's a model that shows it. And I don't know, it's just useful anatomy. It's helped me identify when I'm all the way into the neck region. When I dissect cadavers, I can look down the armpit and I can follow the artery and I can see that muscle, okay? And so that rule is always true. I've never seen a genetic difference there. This model doesn't show it, but it does show those blood vessels that I just charted out for you. So I tried to include pictures of models that are in the room, so you know which models to study when you have a lab time. Right, but I do want to get back to the heart. I'm trying to get you ready for your sheep heart dissection on Monday. So be looking ahead. Monday is a dissection, so you have to come dressed appropriately for lab. In proper footwear, eye goggles, and gloves. That's one lab you don't want to miss. Okay, it's one of our mandatory labs. Missing a mandatory lab could be a problem for you in December, so be sure you're here that day. Now, when they remove the heart from the sheep, be thankful you don't have to do that. They don't do a good job cutting the heart out. Okay. They may cut off this whole top here and you may not see anything. But I list them anyways, and usually if it's not there, obviously you get a pass, but at least you can point to where it would have been, right? And so be able to name all the blood vessels that you had to cut to remove the heart. You had to cut 4 pulmonary veins, you had to cut superior inferior vena cava, and you had to cut the aorta and the pulmonary trunk. So there's the empty space, which is the pericardium with no heart in it. Okay. What's this down here? That's the diaphragm. Holds the heart in place inferiorly. So when you get the heart in your hands, it's going to be fresh. It's not preserved, so they're bloody. I tend to tell students to use only that chrome sink in the back and rinse your bloody heart off. Okay, because you want to minimize, bloody gloves throughout the lab. So if you give it a good rinse from the start, you minimize that. be sure you have your eye protection on. If you get something in your eye, we do have an eye wash. And the procedure is to wash your eyeball in a stream of water for 10 minutes. Now that is very painful. It would just be better if you wore your eye goggles, okay? So I just want to give you a fair warning. I had to have a student do that one time. You know the mistake he made? He wore his goggles, but he wore them on his forehead. Okay, that doesn't work. You gotta wear them over your eyes. Then you won't have to stick your eyeball in a stream of water. We will not subject you to that. So the other thing is, we use scalpels and sharp instruments. If you have a poke or a cut, let me know. We have a first aid kit here. The scalpels are extremely sharp. But the one thing you do before you make any cuts is just get the heart in your hands and take some time to figure out what's the front, what's the back, what's the bottom. Okay. Once you get that, you're off to a good start. And we'll have 10 groups, so you have to form groups of about 3 to 4. I hate to say it, but there's always one group that studies the back and you think it's the front. You kind of waste the first half an hour. Just try not to be that group, okay? Figure out the front and the back, you get moving pretty quick. So let me give you some hints about how to tell the front and the back and so on. And I already gave you some hints. Look for the 2 Dumbo ears, the right and left auricles, because those are part of the atria for the anterior surface. Right, left auricles. Look for the anterior interventricular sulcus. Look for the apex of the heart. I mean, you go down that checklist, you're looking at the front. Okay, now of course you can still misidentify things, but if you're really unsure, just come ask me. But try to figure out yourself. I think that's the whole point. I could tell you everything, but then what's the point of you doing it? So what I did was, I put the model next to the picture. Maybe when you have your heart, if you wanted to have a model kind of as a reference, that's fine, but I kind of cringe at that. Don't touch the heart models with your bloody gloves, is the thing, okay? There's ligamentum arteriosum. That's another thing. You got your structures list. That will help you identify the anterior surface, though. Let me list it over here. Ligamentum arteriosum. Now, this is a remnant of fetal circulation. Remnant means when you were a fetus, you're using it. Now you're an adult, you're not using it. Remnant of fetal circulation. So now it's just a ligament. But when you were using it, it was a bypass. It went straight from artery, it went straight from pulmonary trunk to aorta. Connects pulmonary trunk to aorta. So the reason why you're using that as a fetus is because you're not breathing. And so you can bypass the lungs. So blood flow went straight from the pulmonary trunk straight to the aorta, and when you do that, you skip the lungs because you're not breathing in the amniotic cavity. It's fluid fill. Okay, well, it's something to look for. You know, and a lot of times now we get these hearts. Sorry, the picture's blurry. They cut it off, and you don't even see some of this stuff. So we just have to wait and see what the slaughterhouse guys did for us. And you can see that the real hearts, they don't look like the pictures. But for example, you can see auricle. Okay. So here's the other surface of the heart. This is not anterior. This is considered the base of the heart, the posterior surface. So the apex is the tip. I should point out the apex. The apex is the tip right there, or right there, the tip of the heart. So then behind it, side opposite, is the base. So when you turn the heart around and see the right and left atria. That's the posterior surface or the base of the heart. So basically you're looking at RALA. That's basically all you can see back there. Now on our models, there's other things in the mediastinum, like the trachea and the esophagus. Well, you don't need to worry about that. On this picture, it's just the heart. Let me show you this surface here. This is the kind of the bottom side, the inferior surface. Sometimes called diaphragmatic. I don't like spelling that, so I just say inferior surface. But diaphragmatic means it's sitting on top of the diaphragm. This is that surface. And what you can see are pretty much the back view of the ventricles. So atria up here, ventricles down there. Look for posterior interventricular sulcus. Let me point it out. Well, on this one it's easy. It's got those blood vessels right in it. It runs more or less straight up and down. Okay. Oh, that's the hole for the stand. I frequently get asked what that is. It's not one you gotta worry about. Right here. So you see that, you're looking at the back. Also from the back view, look for the coronary sulcus. Inside the coronary sulcus lies the coronary sinus. Coronary sinus carries deoxygenated blood, drains into RA. It's draining the blood from the myocardium, from the heart muscle itself. Well, let me point it out. The sulcus and the sinus are basically pointing at the same thing. It's number 34 right there, right? But it's this blue vein, and it's in the coronary sulcus. It's pretty much the border between atria above and ventricles below. So these sulcus that you're looking at, I think we're starting to realize hearts kind of don't look like this at all, but just to give you a simple illustration, that anterior interventricular sulcus, it's right down the two ventricles. It goes right down to the apex. The one on the back, the posterior interventricular sulcus, it connects to the one in the front. So they connect front to back. And because there's blood vessels there, that's considered an anastomosis. When blood vessels connect. Let me write that word down. Anastomosis. For example, when an artery connects with another artery, it's anastomosis, because it's not the usual artery capillary vein back to the heart. So this allows for like what they call collateral blood flow. Could help if you have a clogged artery in the heart. It might prevent a heart attack. Well, anyways, those are the two sulcus front and back connecting to each other. The coronary sulcus goes around between atria and ventricles. It wraps around the backside. It goes all the way around front to back. So That's why we mentioned them. They're good landmarks. I think that's all you got to know for that surface. So that's your challenge. Okay, I can tell and identify a lot of different things on the different surfaces of the heart. Then you can kind of start to cut things open, and there are different ways you can cut the heart open. I have to look at my protocols and decide which one we're doing, and I'll check out, see what I have on Canvas now. But anyways, what you could do is look at the internal features of each chamber. Here's right atrium. And are you noticing how there's a lot of pictures of the models in the lecture slides? Do you remember how I used pictures during the lab practical? If I decide to do that for lab practical too, I'll just pull them from the lecture slides. I'm not going to make a special document for that. Since they're already there, you can just look at them. I think it's good to try to make a model look like the picture that I took. You get a better sense of what's going on. And I opened the right atrium so you can see the pectinate muscle right there. See how the muscle fibers, it looks like someone took a comb and combed it. And that's the appearance of the muscle. So it's called pectinate muscle. So look for that comb-like appearance. You have to kind of invert. Well, you got to cut the heart open to see it. That's something I'll have to identify. The other thing that you can see on the picture, it's kind of hidden in the model, this shallow depression is called the fossa ovalis. Write that down. I have no descriptor for pectinate muscle other than it's cardiac muscle. It contracts, okay? But for fossa ovalis, the term means, well, oval shape. Fossa is like a shallow depression, okay? It's a shallow depression in the inner atrial septum, the septum between RA and LA. It's an, oh, sorry, I misspoke, depression. It's another remnant of fetal circulation. It used to be a hole between RA and LA, another lungs bypass. But in adults, it kind of closes, and it just looks like, it's a structure you can identify, basically, in the right atrium. Let's see here. You know, you should also look on the inside. Orifices for, when I say orifices, you know, there are three major structures that drain blood to this chamber. This chamber receives blood from superior inferior vena cava and the coronary sinus. So when you look at it from the inside, you should see those three orifices for those three structures. SVC, IVC, coronary sinus. So I list that. Okay, let's move on. So this has the a full view of the right atrium. Here's the interventricular, anterior interventricular septum. Looks like they went over a couple centimeters and just followed that sulcus and cut along this right margin. You got a full view of the ventricle. And the model makers, they always kind of make it open for the classical dissection perspectives. So inside the RV, one thing to note is, well, you should expect to be able to identify two valves for the RV. Remember, you got the tricuspid and the pulmonary valve. Tricuspid pulmonary valve. Now, the tricuspid valve, associated with it, cornea tendineae papillary muscle. Write that down. heartstrings and the muscle, I taught that before. I'm just relisting them here to remind you. Also, the muscle on the inside of the ventricles, it's not smooth. It looks like it's very rough in appearance, and they call it trabeculate carne. Which means crossbars of flesh. It just describes the internal appearance of the muscle inside this ventricle. The other thing I mentioned that's in RV, not LV, is the Conus Arteriosus. It's just the funnel part of the ventricle. I would put the sticker right here, or I'd point it right here, right before the valve. Now compare this shape with this shape. The left ventricle looks a little different. You can see the left atrium and the left ventricle in this view. So I'll just change that to an L. I'm going to leave pectinate muscle because you have that. You usually don't see phosphovalves on this side. Now let's remember what drains into the left atrium. It's receiving blood from your lungs. So it's getting the oxygenated blood. There's 4 orifices for those pulmonary veins. You should be able to identify them. For the LV, it's the bicuspid valve. And I guess I'll relist chordate tendidae. Papillary, you still have trabeculate carne, but there's no Conus Arteriosus. It's all the same stuff. And I should also mention it's out of sight, but you should also be able to identify the aortic semilunar valve. I won't write it down, you can't even see it here. That one's always, you gotta kind of have to look for it. Well, what I'll tell you to do if you want to get a really good view of it, take scissors. If you cut down the artery straight up and down and just fillet the whole thing open like they do, you can see the valve really good. So if you want to see the aortic valve, it should be right around there. Just take scissors, cut straight down all the way, and just like spread it open and then look for it. And even though you got it open, it doesn't look anything like the pictures. Usually the cusps of a valve, you don't see them, and I have to point them out to you because they're very frail, and it's not what you expect. It just isn't. That's why we do dissections. Nothing looks like the book. Okay, well anyway, I want to move on. And those are all the internal structures you should know. I think one of the biggest challenges is that, like I said, in the theme of it's nothing like the book, you mistake ventricles for you think the atria are the ventricles. Okay, that's probably the biggest mistake I see. Because the way they illustrate them, they look big and cavernous, and they don't look anything like that. So that's the pectinate muscle, that's trabeculate carne. I think the best way to know that you're in the atria, not the ventricles, is to look for the Dumbo ears, right? There it is right there. So if you got the Dumbo ears, if you're kind of in the same area, you know it's the atria, not the ventricles. And look at the thickness of the wall. Compare that thickness to that thickness. This is like a steak. This is like, I don't know what, it's super thin. Okay, that's another way you could tell if you're in ventricles. not atria. All right, but you'll get the hearts tomorrow. You'll see everything I'm talking about. I want to talk about the different parts of the aorta in this lecture. Since one of our heart models, it goes all the way down to thoracic aorta. So from this picture, we learn the artery doesn't change, just the name. Coming off the heart, it's the ascending aorta. And then it arches. So they call it the aortic arch. That is right behind the sternal angle. Okay. I like to give the landmarks. You can always feel it. I can feel my sternum. I can feel, oh, okay, it's right around there in my chest. And then it descends all the way back down. And after it goes through the diaphragm, the descending or thoracic aorta becomes abdominal aorta. And so notice the name refers to the direction of blood flow. Descending means blood is going down. Yeah, okay. Or you can call it thoracic aorta because it's in the thoracic cavity. Now the thing about it is, this is the main artery and it branches. So that's another thing I want to mention. Arteries branch. What do I mean by that? You have a tree trunk, like branches on a tree, and it branches out. It branches out. And maybe this one branches out. But you start from the trunk, and as blood flows through, it flows through the smaller branches. And so sometimes they call branches of arteries branches. And it's a remarkable source of confusion for students. There's one branch I'm going to teach. It's called the Circumflex Artery. Sometimes it's called Circumflex Branch because it's a branch. Okay, so don't let that confuse you. The thing about veins is veins don't branch. The thing about blood flow, veins return blood. So it's collecting from the smallest capillaries. So the smallest veins have to collect that blood. And then the veins merge into bigger and bigger ones. Here's a small vein, and it's going to merge with this small vein. That'll be a bigger vein. And this bigger vein is going to collect blood from this bigger vein and becomes even a bigger vein, and that, so forth and so on. So it starts here. It's collecting blood from the smallest vessels. It becomes bigger and bigger and bigger. So veins don't branch, do they? They're merging. And so they call veins more like tributaries, not branches. I think on one of my study guides, it says circumflex artery. But you know what the key says? It says circumflex branch. Do you know how many questions I get on that? It's unbelievable. It's like, is this the same thing? Yeah, I don't know. It's just one of those, that's one of the questions that annoys me. Don't ever ask me that. Branches are arteries. It's the same thing. And so that's something to keep in mind as I teach the branches of the aorta. The first 2.5 centimeters are the ascending aorta. The branches coming off the ascending aorta supply blood to the heart. Okay, and I try to draw like boom, boom. Okay, that's left and right coronary arteries. So notice how short the left one is. And this is another common mistake on lab practicals. The tricky thing about the left one, as soon as this is a branch, the left coronary artery is a branch of ascending aorta. But then the left coronary artery branches right there into two. And as soon as it branches, it stops. It becomes something else, and I'll go over those branches later. So that's why students always miss it. Like I'll label it after it branches, and you call it left coronary artery, and that's wrong. After it branches is it, okay? So it's much shorter. But the right one gives off branches, but it retains its name, right coronary artery the whole way. Anyways, those are the two branches of the ascending aorta. These are extremely important. They're supplying blood to the heart. When you have a heart attack, it's a clogging of these arteries or branches of them. All right. So a heart attack is an acute myocardial infarction where over time, due to poor diet and physical inactivity, you develop these blockages, these lesions, and over time, they calcify. They get hard and brittle on the inside of your soft blood vessel. So when you have hard tissue on soft tissue, that creates problems. You ever get a scab? You ever pick at the scab? Where you pick at the edge, right? So on the inside, where it calcifies, you get hard tissue, soft tissue. At that border, at the shoulder of the lesion, soft tissue, hard tissue, that's where it breaks. And when it breaks, you get this huge thrombus or blood clot. That causes a heart attack. And it happens here, that's called a heart attack. When it happens in the brain, it's called a stroke. Anyways, so these are those arteries. Okay, and I'll teach you the branches of them later. I'm going to continue on with the rest of the aorta. The next part is the aortic arch. Look at the picture on the left, it's easier to see. Well, the aortic arch, if I were to draw a line here, it's about the level of T4 vertebra. So it begins and ends at about that level. Begins, ends, level of T4 vertebra. And those branches at the top, 1, 2, 3, from right to left, are called the center of arterial circulation. They supply a lot of blood to major regions. So one is brachiocephalic trunk. It's an artery. Sometimes they call arteries trunks. Number 2 is the left subclavian. I'm sorry, the left common carotid. Got ahead of myself. Left common carotid. Number 3, left subclavian. They're all arteries. And you can call the brachiocephalic trunk, not artery. So the question becomes, where's the right common carotid, right subclavian? There are branches of the brachiocephalic trunk. So if you follow number 1 up on the picture, there's brachiocephalic trunk. It'll then branch into the common carotid and the subclavian on the right side. Notice it's spelled carotid, but we pronounce it carotid. I don't know why that is. Okay, but don't misspell it, right? Because you lose points for spelling. It doesn't matter how you pronounce it. Well, I guess when you get a job, you should pronounce it right. You don't want to say things wrong. Okay, so right subclavian. So on the left side, the common carotid and subclavian, they're direct branches off the ascending aorta. But not on the left side, they come right off the aortic arch, but on the right side, because again, the artery is a little bit more on the left side. So to get to the right side, it has to send the brachiocephalic trunk a little ways to the right, and then it can branch into the common carotid and the subclavian. So on the left side, you're already on the left, so you can be direct branches off of the aortic arch. Well, anyways, be able to identify those three. And then as the artery goes down, here's a backside view of the thoracic aorta. See these paired holes? What do you have pairs of in your rib cage? Pairs of ribs. So these are paired posterior intercostal arteries that branch off the thoracic aorta. So I don't want to draw all 12 pairs, but I'll draw a few. So the thoracic aorta, the branches are the posterior intercostal arteries. You can also call it descending aorta. Anyways, branches are, there's other branches too, but just know the posterior intercostal arteries. Should be 12 pairs of those. So we move on. There's a picture of the thoracic aorta. It runs from the level of T4 all the way down to T12, and then becomes abdominal aorta. So it goes from T4, T12, T4 to T12. I'll teach the abdominal aorta later when I teach the digestive viscera. I want to go back to the coronary arteries and teach the branches of the coronary arteries, okay? So I just listed on one slide the branches of the RCA and the LCA. So I'm going back to here. And I'm going to teach the branches of those. So if you follow the right coronary artery, it's going to go all the way to the right margin of the heart. It's going along the coronary sulcus, and it goes all the way to the right margin, and it gives a branch, and it's called the right marginal artery, because this is the right margin of the heart. Now there's a left marginal artery too, but I'm just teaching the right. That's considered one of the major branches of the right coronary artery. So it's going to give a branch, and it's going to follow the right margin of the heart. That'll be the right marginal artery. So let's start to number these. Let's go number 1. right coronary artery. Coming right off ascending aorta. But as it runs, it gives off this first branch, right marginal artery. So it's going to continue along the back of the heart, the coronary sulcus. So I'm going to go dotted line. And it's going to go down the posterior interventricular sulcus. This can be called posterior interventricular artery. Call that number 3. Posterior interventricular artery. If you follow the left coronary artery, call it number 4. It branches very quickly, and there's one branch that goes right down the front of the heart in the anterior interventricular sulcus. So let's call this branch number 5. Anterior. Interventricular artery. Also called left anterior descending. You can call it that too. Left anterior descending. So think where it is. It's supplying blood to the LV. This is dubbed the widowmaker. If you have a heart attack here, because it's LV, if it's large enough, that could be lethal. And because it's widowmaker, the male gender is a risk factor for heart disease. Okay, men tend to have a heart attack a little bit more. But anyways, the name of the artery, anterior interventricular artery, that's the commonest anatomy name. In clinical circles, they call it left anterior descending. You can call it that. You can see left anterior descending or anterior interventricular connects with posterior interventricular. So they meet from front to back. So, okay, because those two sulcuses and the lymph vessels, they connect. That's an anastomosis. If you follow this branch around, well, I'm not drawing it very well. It's the one that's going to wrap around the back of the heart. It's called the circumflex artery or circumflex branch. So this is branch number 6. You can call it circumflex branch, circumflex artery, I don't care. It's the one going around the back of the heart. So it's actually useful to look at the front view as well as the back view. Let's check this out. From the back side, you can see the right coronary artery. And then you can see the posterior interventricular artery or branch. Let's see here. They're circumflex. They show a bit of it there. Okay, let's talk about the veins that run with some of these arteries. The one that runs with the posterior interventricular branch is the middle cardiac vein. All right, go back to this view. The one that runs with the right marginal artery is the small cardiac vein. Call number 2 in blue, small cardiac vein. And the other one that runs with the anterior interventricular artery is the great cardiac vein right there. Now all of these veins, that's it. I just gave you 3. There's many more. Just know those 3 that they run with the arteries. So anyways, those 3 veins, we're going to go back to the posterior view again. They all drain into the coronary sinus. So know that one too. All right, so we have the heart valves. And so this picture, if you chop the top off the heart in the perfect plane, you can see this view with all 4 valves in the same plane. So I just kind of labeled it. You should be able to identify valves from a picture like this, in addition to like the ones we looked at earlier. But yeah, the pulmonary trunk and its valve, they're most anterior. That's what you'll see first on your sheet part. If you cut them all open, this is what you see. I think it's good to note that the coronary arteries, right here, those are the openings. Do you see how they're right next to the valves of the aortic valve? That's actually a super important detail. Well, okay, here's detail number 1 why it's important. On your sheet part dissection, I want you to show me that orifice. Write that down. Be able to show, I'm going to erase this now, I don't need it. Show orifice of a coronary artery. So the right and left coronary arteries are the lifeblood of your heart. They're called coronary. If you isolated all the coronary arteries and their branches, it looks like a crown of thorns. Coronary means crown. Notice they use coronary for arteries, not veins. Don't call them coronary veins, that is incorrect. They're cardiac veins. But anyways, for the coronary arteries, be able to show the orifice. It's going to be right above the valve, right there. Okay. There's 2 of them. I'm just like, just show me 1. And you'll be good. The other thing is, because they're right by the valve, when the valve opens, it blocks the orifice. So when valve opens in systole, it blocks the orifice. So the heart does not get blood during systole when the heart is contracting. So the ironic thing is the whole body is getting blood from the heart pumping, but the heart itself doesn't. But when the valve closes during diastole, blood can flow to the heart. So the important thing is coronary blood flow is restored in diastole. When the heart muscle is relaxed. So when your heart relaxes, it gets its blood. It makes kind of metaphorical sense too. So anyways, be able to show me that orifice. Sometimes this is a test question. That's why I'm kind of putting stars next to it. I don't know if it'll be this time. But you've been warned. The other thing about the valves, we study them in cardiac cycle. That's kind of why I mentioned them now. That's kind of next. So basically what we see here is, well, I'll teach you the phases of the cardiac cycle. But notice how these three things, one of them is going to be true no matter what you're studying. When you fill the heart with blood, that's called inflow. But notice these valves are closed. So when the AV valves are open, SL valves are closed. That's inflow. Okay? That's when the heart's relaxed and filling with blood. That's diastole. Hey, let me erase this. Let's start to think about the cardiac cycle. Ventricular diastole, systole. There's another thing where it's like, it's spelled diastole, but how do we pronounce it? Diastole. It's like carotid, but we spell it carotid. It's kind of like that. So when I listen to students in lab, and I hear these mispronunciations, they forgot, they weren't paying attention. That's kind of how as my ears perk up. So it's diastole or systole, but spelled that way. Okay, so when the heart muscle's in diastole, it's relaxed. Low pressure, it's filling with blood. That's inflow. When the heart is contracting, that's outflow. And then the valves of the arteries open and these close. Okay? And valves opening and closing make the heart sounds. Specifically, the valve opening doesn't make a sound. It's when they close, that's when you hear the sound. Make heart sounds. Well, there's many heart sounds you could teach. It's just pretty much lub, dup. When the AV valves close, that's the lub sound. When the SL valves close, that's the second heart sound, the dup. Now, if I ever ask you that, don't misspell lub dup. It seems silly to say it. You know what students always do? They go dub lup. I'm like, what the heck? Which one's which? So I just mark it wrong. Don't misspell that one. Let's see here. Okay, well, here's, if you cut a little lower below the valves, you can see the shapes of the right ventricle and left ventricle are very different. This is more circular. This is kind of crescent shaped. So when the heart's relaxed, dilated versus contracted, you can see what happens. You're squeezing blood out. Okay. If you could fill your ventricles with water in the lab and just squeeze it until it squirts out, but don't do that, it'll make a big mess. You could do that, but that's what your heart does when it pumps the blood. It's not really pumping it, it's squeezing it, okay? But in squeezing, you generate the pressure that pumps it out. Here's a picture of the sheep heart dissection. And the pictures, I did this during lab, and I pulled my phone out, and students are moving around and trying to get a good picture. But I think we can see some things here that I've labeled for you. Once again, can you tell the front from the back? Here's some extra credit opportunities for your dissection on Monday. Pay attention, because I'm not going to remind you, and you love extra credit. The visceral pericardium gives the heart that glistening appearance. If you can dissect it off the heart wall, I'll give you, I don't know, 1 or 2 points, depending on how good it is. That's pretty good. Most students can't do that. I guess one student saw it and said, I'm going to outdo them. I've never seen anyone do that. Okay, that's pretty good. In fact, I don't want to say it, but probably none of you can do it. I don't think I could do that. That's really hard. But some of you guys have very good hands. The other thing, I haven't taught this yet. There's an electrical conduction system. I'll probably teach it, maybe today or Monday, called Purkinje Fibers. Purkinje Fibers. Do you see the roughness of the muscle? That's trabecular carne. See how these are whitish? See how these are whitish? But these are chordae tendinae. That's papillary. That's the valve up there. But this whitish, that allows the electricity, the action potential to spread through the heart very quickly, and those are called Purkinje fibers. If you can identify Purkinje fibers, I'll give you bonus points. Bonus.
They just provide action potential?
Yeah, they allow the action potential to spread.
Okay.
Yes, that is correct. They make the ventricles contract really hard and fast. Well, let's take a break. We'll come back from break. We'll do the cardiac side. Come back at around 9.